Okay, so here we've got a very interesting IGCSE exams question, which is part geometry, but really it's about ratio and proportion. So we've got to calculate the length of PR, which is from here to here, based on the extra information that we've got in triangle ABC, and knowing that ABC is mathematically similar to triangle PQR. So that's the challenge. And in part B, we've got to calculate the area of triangle PQR. Okay, let's have a look at the examiner's remarks. And they say part A was well answered, although there was a commonly seen answer of 11, which was when people subtracted 8 from 14, getting 6, and then added 5. Well, that's going to give them an incorrect answer. For part B, the common incorrect answer was 28, which was when students used a linear scale factor rather than an area scale factor. And we'll have a look at what that means as we work through the problem. Finally, it says there were some attempts to use the area formula, which is not this one, which is for right angled triangles, but this one, half AB sine x, which is the formula that we use when we're calculating the area of a triangle that isn't a right angled triangle, that's an irregular triangle, if you like, for areas of triangle. However, this was often unsuccessful. Okay, so those are the examiner's remarks, and let's work through the question. So, part A, we've got to calculate the length of PR. Well, if PR is y, then y must be directly proportional to this length here. So PR is directly proportional to AC. And so y equals some constant of proportionality times the length of AC, which is 5. And I'm just going to write that the other way around, because what we're producing here is a bit of algebra, so it's better to write it as 5k. Okay, so y equals 5k. Well, we've got two variables there, and so we don't know what they are. Well, we've got a constant here, but we don't know what that constant is. So to find that constant, we can substitute this variable for 14, which it corresponds to this 8. So we've got 8k now. And now we can find k. So k is 14 divided by 8, which is 7/4. Now we've got our constant of proportionality, we can come back to this formula here and solve for y. So we've got 5 times 7/4, giving us 35/4. And that equals 8.75. We're going to decimals because we're talking about centimetres, so we generally want that in decimal format. So 8 3/4, or 8.75 centimetres. Now that's how to do it by finding the constant of proportionality, but it's a good idea to check that we've got the right answer. And we can do that just by using kind of mathematical reasoning. All we need to do is say, well, let's do it over here. If we've got 5 to y, so the relationship of this to this, that must be the same as the relationship of this to this, because they're corresponding. So we've got 8 to 14. Okay, so how do I get from 5 to 8? I must multiply by 8/5. So that must be the same as I move from y to 14. Again, multiplying by 8/5. So y times 8/5, or 8/5 of y, equals 14. I'm running out of room here, but here we go. So then I've got 8y equals 70, and y then equals, or 70 divided by 8 is going to be again 8, and 8 eighths is 64, so that's 6 eighths, so it's going to be 8 and 3/4. 6 eighths are 3/4. So the answer that I got for part A using the constant of proportionality must be correct. Okay, now slightly more tricky is part B. Let's do that here. So for part B, the constant of proportionality has to be squared. And that's because if we've got corresponding lengths that we're scaling up by 7/4 to get from the 8 to 14, for example, it's going to be that's if it's a length, it's going to be scaling up by a length and a breadth, if you like, 2 dimensions, when we're going from this area here, which is 16 centimeters squared, to this one here, which we don't know. So it's going to be length times a length, if you like, or length squared, which is why I'm going to scale up this from a linear constant of proportionality to an area constant of proportionality, or area scale factor, if you like. So it's that key idea that caused a lot of people not to get the marks for part B. Anyway, here we are. So we're trying to find k squared, and k squared is 7/4 squared, which gives us 49/16. So now we've got our scale factor for the area. We can say, therefore, area of PQR must equal 16 times 49/16, and here nicely the 16ths cancel to just give us 49 centimeters squared. Okay, that completes the question, but let's again do a check, and I'm going to do a check by calculating the area using the area formula as suggested in the examiner's remarks. Let's do it in a different colour, and we've got to use the area of, well, let's start with ABC. So area of triangle ABC is, and the formula for the area of a triangle is half times A times B times the sine of X. Well, X, let's see, it's a different colour here now. X is going to be the angle between these two values here, the angle between these two sides. So this is X, and that's going to correspond to this angle here. So just as the sides correspond, if the triangles are mathematically similar, so must the angles. Okay, so now going back to this, we can just plug in our values. All right. So we know that the area of triangle ABC is 16 centimeters squared. So 16 equals half times A. Well, A, let's choose 8, and B, 5. All of that is multiplied by sine X, which means that sine X must be, so therefore sine X is going to be 16 divided by this. Well, what's this? Half of 8 is 4, times 5 is 20, so sine of X must be 16 divided by 20. Okay, so now if we move on to the area of triangle PQR, that's also going to be half times A times B. Well, A is 14 times B, and we now know that B is this length y, which is, and I'm going to use this here because that's going to be easy to work with than this. So b is 35 fourths. So half times 14 times 35 fourths times the sine of this angle x. Well, we now know that the sine of this angle x is 16/20. And that simplifies to divide top and bottom by 4/4. So now I've got four numbers which multiplied together will give me the area of triangle PQR. And I'm hoping it's going to be 49. Alright, let's do the calculation. So half of 14, nice and easy to do, is going to be 7 times 35 times 4, so let's say 4 times 35, divided by 4 times 5. So these 4's will cancel, and we've got 5 into 35 is going to be 1 on the bottom and 7 on the top. 7 times 7 is 49 centimetres squared. So we've got an agreement, which means we can say this answer must have been